Okay, here we go, guys. Day 7, called Inscribed Angles. This will be the last topic that will be on your quiz that you guys are going to access sometime next week. Okay, so this is the last topic. So you got day 1 circumference all the way through now day 7 inscribed angles. Okay, so what is an inscribed angle? Well, first I want to quickly review with you what a central angle was, if you remember those. That is an angle where the vertex is the center of the circle. Okay, so here is my central angle. Okay, inscribed angle, much different. The vertex of a central angle now is somewhere on the circle. Okay, it's somewhere on the circle. Okay, so angle DEF is a central angle. Okay, why? Again, because the vertex is somewhere on the circle. And the other two sides of the angle are chords. All right, that's important that those are chords. All right, so again, inscribed angle, vertex on the circle, and the two sides of the angle are chords. All right, another example I can make here. You can also have a diameter involved too. That's fine. There you go. So now I have angle ABC, which is also an inscribed angle. B's on the circle, AB and BC are both chords. Now, the big thing we got to talk about is how do you find the measure? Because remember, up here, the measure of a central angle was equal to its arc measure, right? Measure of its arc. Inscribed angle, a little different, all right? The measure of an inscribed angle is equal to half the arc measure. Okay, so it's not equal to like the central angle, it's equal to half. So for example, in my diagram up above, angle DEF is equal to half the measure of what arc does DEF make? Half the measure of arc, excuse me, DF. Okay, that's how that works right there. And, you know, let's keep going here. Why not? Angle ABC, that inscribed angle, is equal to half of, you guys can guess, arc AC. Measure of arc AC. Okay? So inscribed angle's got to be on the circle, and it's equal to half its arc measure. All right, let's practice using it now. Why not? All right, we got an inscribed triangle, ABC. All vertices are on the circle, so we have 3 inscribed angles. Find angle A is 80, arc AC is 88. I've already labeled that on the diagram for you. Let's find all these different pieces now. Okay, so here we go. First one, arc BC. Arc BC. What is arc? Again, the measure, not the distance or the length, the measure of arc BC. So I'm looking for my angle in degrees. Well, if you take a look here, 80 is an inscribed angle, and it is drawn to that arc we're trying to find the measure of. So I would be taking half of BC, and I'm just going to write this out so you can see it. I'm not expecting you guys to write out because you could probably already know the answer, but half of whatever BC was is equal to that inscribed angle of 80. Half the arc is equal to the angle. So what did I take half of to get 80? Arc BC must be $160. Okay, so 160, I'll put it on my diagram. All right, how about angle B? Well, if you take a look, angle B is an inscribed angle. So I know I'm at least going to take half of something if I'm finding an inscribed angle. It's half of what arc? What arc belongs to angle B? It's arc AC, which is 88. So I'm going to take half of 88 and get 44 degrees. Okay, so that one right there is going to be 44 degrees. How about angle C? All right, a lot of different ways we can do angle C. Guys, why don't we just stop wasting time and get right to it, right? I have 2 out of 3 angles of a triangle, so I know angle C is going to be 180 minus those 2 angles. minus 80 minus 44. If you go to the calculator real quick, that'll be 56 degrees. Okay. And then finally, arc AB, a couple different ways we could do it. I know 2 out of the 3 arcs of a circle, so I could take 360 and subtract 88 and 160, or I could just take that 56 I just found and double it, because 56 is the inscribed angle to arc AB, so I could double it. Either way, it's going to get me to 112 degrees. All right, so working with inscribed angles and its arcs, hopefully that wasn't too bad. Moving on. All right, find the values of A and B. Whew, all right, we got a lot going on here. All right, a lot of lines flying around, huh? Okay, so let's start with A now. Okay, arc A. Now, if you can see here, guys, I'll highlight it. Arc A belongs to this inscribed angle right there. All right, that's what arc A belongs to, is that inscribed angle. All right, so what I can say is A must be equal to that 60, but doubled. So A should be equal to $1.20. All right, so hopefully everybody is good with that part. All right, next up, let's get rid of that. And let's go to B. Now everyone take a look at angle B now. Angle B is an inscribed angle. Okay, I'm exaggerating here so you can see it. Angle B is an inscribed angle, which means it's going to be half of, now take a look at the arc. All right, take a look at the arc that's in between it. I'll do that in yellow. It's got to be half of, not just that, all of it down to S. All right, all of it down to S. So it should be half of, I'll do the arc right here. It should be half of arc PTS. All right, and if you take that, that should be half of, let's see, PTS consists of the 120 I just found and the 30, that's TS. So that's going to be half of $1.50 or 75 degrees. Okay, so you got to make sure you know what arc it's going to so you can take half of it. All right, next up, we got a little box here because we're going to write a theorem in there. All right, what I need you guys, I kind of want you guys to come up with a theorem right now. So what I want you to do, draw me a circle. We'll call that B in the middle. Let's get some chords flying here. What do you say? Let's do inscribed angle AEC. So let's draw that AEC. And we're going to make another inscribed angle and call it, looks like ADC. So ADC, there's D. Okay, everyone see the 2 inscribed angles I've created, E and D and A and C. Can you tell me anything about them? Let's start with E and D. E and D, both inscribed angles. Can you tell me what arc they're drawn to? The same one, right? AC. Both E and D belong to arc AC, which means if I take half of the same thing, E and D should be congruent to each other. Look at A and C as well, angles A and C. They're both drawn to which arc? A and C are both drawn to arc ED. Yeah. So they're congruent. What allows me to say this, and now I can use this in a proof, which I probably will. I have what we're let's start E and D. We're what? 2 inscribed angles. And what was being done to them? They were being 2 inscribed angles. They were being drawn to the same arc, are congruent. Okay, so heads up right there, guys. 2 inscribed angles drawn to the same arc are congruent. All right. That's a big one here. We could use in proofs or any algebra problem too. All right, moving on. More inscribed angle work. We have find the values of X and Y. Got it. And arc BC. Ooh, okay. Got it there too, huh? If AB is a diameter and ABD is a straight line. Got it. Okay. Well, AB is a diameter. which makes this a what then? What is that right there that I just highlighted in blue? If AB is a diameter, that is half a circle, right? Also known as a semicircle, which is how many degrees in a semicircle? 180. And if you take a look, angle X is an inscribed angle that's drawn to that half semicircle. So because it's inscribed, angle X is inscribed, I'm going to take half of the arc, which is a semicircle, a $180, and angle X ends up being a right angle. Okay, that ends up being a right angle. All right, no issues there. Okay, so we now know that that's a right angle, which makes Y a little bit easier, right? So I know 180 degrees in a triangle. I know one angle is 90, the other is 58, so I can subtract those and end up with 32 degrees. All right, and then finally, it's asking for the measure of arc BC. BC belongs to inscribed angle Y. All right, if you take a look, highlight it in red. Here's angle Y. It's drawn to arc BC. So if the inscribed angle is 32, how do I find the arc? I can double it. So that'll be 64 degrees. All right. A couple other theorems here before we go into one more question. Notice how, remember we found angle X to be a right angle. Okay. I don't need to do the algebra anymore to figure out that that's a right angle. I can use this following theorem that if I have an inscribed angle, which was, I'm just going to make some notes here, an inscribed angle, which for us was angle X, intercepts a diameter or a semicircle, which was for what? That was arc AB for us. It is a right angle. Okay? So an inscribed angle that is drawn to a semicircle or a diameter. You can use either word. All right? You can use either word, diameter or semicircle. It's a right angle. Okay? So inscribed angle drawn to a diameter is a right angle. Done. All righty? And then finally, I love this one. Love it, this last theorem. And again, I'm sorry, guys. I tried to warn you when we started the unit. A lot of theorems, right? If I have a quadrilateral inscribed in a circle, so a quadrilateral inside a circle, so all four vertices are touching. So quadrilateral ABCD. Its opposite angles are supplementary. The opposite angles are supplementary. So in this case, angle A plus angle C, remember supplementary means they add to 180. Angle B plus angle D equal to 180. Okay, and if we were in class face-to-face, I'd take the time and show you why that's true. It's actually pretty neat why it's true. All right, why it takes up a half circle, but I guess you're just going to have to go with it. All right, so in a quadrilateral inscribed in a circle, opposite angles are supplementary. So I'm going to let you guys go ahead and try example 4 out, which is an old Regents question. Okay, so you try it out. I'll put my work down, and then we'll see if we match when we come back. All right, so pause that video, and let's get to work. Coming back at you. We had GFE, which is this arc right here, GFE. And that arc belongs to inscribed angle D, which was 86. So I doubled 86. And then for part B, find angle F. Well, angle F, if you notice, I just used the theorem I just showed you, which is if you have a quadrilateral inscribed in a circle, which I do, that the opposite angles are supplementary. So I knew 86 and angle F had to be supplementary, so that's why I subtracted from 180. Okay? So get going on that bookwork, see how it goes. I'll see you in the Google Meet for questions, and then we'll talk quiz as well coming up next week. Take care, guys.